Alright, so for our learning target for today in math is I can decompose non-unit fractions and represent them as a whole number times a unit fraction using tape diagrams. There's a lot of language in that learning target. So we are going to use the tape diagram from our do now. And this tape diagram represents 1, 2, 3 fourths. We know that in unit fractions, each of these rectangle squares in our tape diagram represents 1/4. So if we were looking for the shaded area of this tape diagram, in unit fractions we would do 1/4 plus 1/4 plus 1/4. And that would equal 3/4. I'll put my equal sign and my 3/4 below. Now, we can use addition, but we also can use our knowledge of how repeated addition is the same as multiplication. So what we're really doing is we're doing 3 multiplied by 1/4 because we've added 1/4 3 times. So we've multiplied with our whole number 3 times 1/4, and that is also equal to 3/4. So we can use this multiplication sentence, and it's a lot faster than writing 1/4 plus 1/4 plus 1/4 over and over again. So for example, if I was going to do it again, I would draw a tape diagram for 2/3. I would have to partition my tape diagram into thirds, shade in 2, and I know that 1/3 is represented in each of these squares or sections. I know that 1/3 plus 1/3 is equal to 2/3. But using my knowledge of multiplication, I could also say 2 times 1/3 is equal to 2/3. Just like with addition, our denominator doesn't change. It's our numerator that is changing when we are multiplying our whole number by our fraction. I'm going to ask you guys to try one on your own. I would like you to draw a tape diagram, write a repeated addition statement using unit fractions, and then use a multiplication equation just like I did right before this for the number 7/8, for the fraction 7/8. You can pause the video right here and then once you are finished drawing the tape diagram, writing the repeated addition sentence, and also writing the multiplication sentence for 7/8, then you can resume the video. The last thing that I want to show you is that we can do the same thing. Don't get tripped up. The way these worksheets are trying to trip you up is when the tape diagram represents more than one whole. So I'm going to draw a tape diagram. I'm going to partition it 1, 2, 3, 4, 5, 6, 7. I ran out of space. I'm going to draw another line, another box. 8. And I'm going to put a hole here. But this tape diagram is actually going to be more than one hole. So I'm going to add 2. You're going to see tape diagrams like this. And you're going to see each of these shaded in. There are 10 total rectangles. I'm saying that because I'm sure it's hard to see through video. But because our one up top doesn't include these last 2, we're looking at eighths. Our denominator is going to be an eighths. Our unit fraction is going to be an eighths. So each one of these squares represents 1/8. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all together. So this is equal to, this whole tape diagram is the equivalent of 10/8. That's what it represents, 10/8. Now, I could write 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 10 times. Or, to make it easier, I can use a multiplication sentence. 10 multiplied by 1/8 is equal to 10/8. Using my knowledge of repeated addition being the same as multiplication, the multiplication equation is so much easier, it's so much more efficient, it's so much faster to write. And that's why we use our multiplication sentences instead of addition sentences. You're going to try this now on your own in the worksheet. If you feel stuck, raise a hand for Mr. Sullivan, or you're welcome to come join my group.